Hi, this is Jim, a LabVIEW mentor, Portland, Oregon. I've one of the most popular videos I have on the channel is the Vision Assistant tutorial that I did some couple years ago. And several improvements have been made to the Vision Assistant, and I wanted to get this out as early as possible so that people can take advantage of it for this season. What we're going to do today is do a real quick overview of the Vision samples because there's a wealth of information there. I also like to refer you to the numerous WPI Internet help instructions and references. These are excellent, especially for anyone that wants to get more involved in image processing, and it's a fascinating field of work for any new student that wants to go into engineering and future work in robotics. Then primarily the focus here, though, is for the Vision Assistant target tracking and how it can be used in this year's game strategy, because it can be hugely beneficial. And what I recommend you'll see is that you put the image processing in the dashboard, one, because ease of application, and two, most of the time the laptop that runs the dashboard has more bandwidth. And what you'll see is I put a crosshair there that illuminates when we have the target in distance. So what I'm going to do is when we get into the tools, is to essentially use the simulator and Vision Assistant to set up the process. And the reason I emphasize that is that even before you get a prototype board, even before you get a robot built with a camera on it, you can do this, play with the technique, verify that you understand the process, and then basically complete it as you get access to either a prototype board with a camera on it or a finished robot. So what I'm going to do is drive the simulator around. During that drive, images are automatically captured in LabVIEW data. So we're going to save those. Then we're going to open up the dashboard project. We use Vision Assistant to identify the shapes that we want to identify. We verify that it works. Then we're going to build crosshairs that will illuminate in the dashboard when we've got the target in range. And then we're going to show it, run it on the simulator and see how it works. When you get the platform with your camera, you can take a step further by actually using illuminated images. You want to make sure that you use a ring LED for illumination. The one that we use is white, but frankly, red is extremely good. And you want to make sure that the target you use is the special reflective tape that FRC uses, because it makes the images pop out on the screen and easier to filter out unwanted shapes. Make sure you try the system once you've got a prototype with various lighting conditions so you understand what the trade-offs are, and it will make the whole process go smoother as you get into the debug part of the robot stage or development stage. And then ultimately you're going to need to capture images in the game conditions if you're using templates. Now there's several ways to analyze and measure the objects, and what you're going to see me do is I actually use an image template, and to be able to use that on the robot, you have to be able to locate, store the template in the platform, and then pass the path along to wherever the program is going to be stored or deployed. And this is another reason to use this technique, which puts the information in the process in the dashboard, because it's always going to be on the driver station. So with that said, let's jump into the process of looking at some of these samples. All right, so I'm starting from the Getting Started screen on the LabVIEW project tools. I'm going to go to Support, and then pull up the Find FRC Example search engine. And what you'll see here under FRC Robotics is they've separated the examples based upon what type of processor you're going to be using. So this is, if you're using an older C-Reel, those examples are set up for that platform. In this case, we're looking at the RoboReel platform. We specifically want to look at what's going on under Vision. And here we have examples from season 2016, 15, 14, and different variables. I think it's extremely valuable to look at these and reference how they do things. I would recommend starting off with Vision Assistant and get a sense for how this stuff is done, because these examples do not use Vision Assistant. They use the Vision platform icons, and consequently they're extremely valuable in terms of seeing how things work, but even more so if you look at the way they put the icons together. So what this has done, I've got this first example, which is the 2016 Vision example, and we're going to look at, if you notice what I did, let's see if I can sort this out. They have two different VIs here on the Project Explorer. We're going to look at the first one, which is color processing example, and then we'll look at the particle classification example. They both use a series of images that are installed with the tool and that fall under this file listing. If you wanted to go out and use your own, you could actually have another series of images that you could reference with this icon. For now, we're just going to use what they've given us. The downside is, so we're going to launch the tool, launch the VI. These are the images that they've captured. If you look at the README file, these are intentionally low exposure images because they want to amplify them over here with the processing. And as we step through each of the images, you can see what's going on. And the fact, there's a couple things. We're at this point, as the image is out of the field of view, it doesn't process as much as ones that are down within the full frame of reference or full field of view. All right. Now what they've, and again, this is, if I look at the block diagram, this is a lot more complicated than, frankly, I understand. But as I go through the process of using the Vision Assistant, I see how it uses these icons. And again, if I use the context help, there's a very clear reference to how to use these particular images or icons, even free-handed. One point I will make is that you'll notice in a lot of places they use this little erase icon to eliminate errors, because apparently there's some sensitivity to using some of these images in video processing. And once, if you get there, if you get to the point of developing your own using the icons and the Vision palette, you may want to liberally spread these error erasure notices just so that there's not, you don't have to deal with a bunch of errors that you can't deduce where they're coming from. At any rate, they have, the WPI websites have a description of what each of these stages do, and while they're extremely valuable, I think they're much more involved than that I need to get to, that I want to get into during a 6-week period we have for building the robot. So again, the value of going through these examples is great, but in terms of what we're trying to do, as we want to focus on building the robot. Okay, so again, go through the examples, look at how they use the different icons, but I think it's helpful to use the Vision Assistant first and then go back and see what you learn. All right, so the first thing I want to do is build an FRC robot project. And I'm not going to go through each of these steps. I'm just going to advance as we kind of get going. But I want this to be first of all, I'm going to set it to tank drive because it's easier for me to work. And we're going to talk about looking at the video. And I want to put my team number in there. And as we do that, it's going to create the project. Okay, I've built I started a robot project. I've changed teleop to tank drive. I'm got my image size here at 320 to 240, and I'm going to target the tank drive to my computer for the simulator. I've also launched the driver's station. I've got the team number in here. I'm using the default dashboard, which is what's here in the background. Now we're going to start the simulator. The reason for going through this is I want to also have my joysticks plugged in. And as you can see that they're on and running. Now as we start this, as soon as we enable the camera, the driver station will start to record images. And I bring this up because one of the things we're going to do is we don't want to, because they continually overwrite themselves after 60 frames, we want to stop this as soon as we've captured enough images. And frankly, the images we want to capture, and I'll show you where I kind of zoom out, I want to get in pretty much to the range that we want to capture or use the images. So I need to have them look something like they're going to look in our. So as I get a little bit closer here to my image, all right. So I'm going to be looking at, turn the camera on, and I'm going to be focusing on my yellow totes. All right, so we're going to kind of scan left to right, scan left to right to left. And it's a little sticky because I have so much going on as far as this little computer with the GoToMeeting stuff. Now that I've got the images that I want to look at, I'm going to go ahead and stop my driver's station immediately, close out the simulator, and then we're going to start working with the project. And I'll show you what these look like in a second. All right, I'm looking at my Windows Explorer here under My Documents, and you'll notice that under LabVIEW Data, if we open up that folder, there's a bunch of JPEG images here, and these are all have been recorded, 0 through 59 or 0 through 60 have all been recorded by the driver station as we're driving around. So anytime the driver station is running with the video enabled, it's overwriting these images. So what I want to do is create a new folder, and I'm going to call this new images that I'm going to play with, and I'm going to copy all of these 60 images into that folder. So let's see if I can do this. So I'm just going to drag, where did it go? I'm going to drag it into the new image. There it is, new images right into there, and I'm going to copy them there. Now as I open that up, you'll see I have all those images to play with. Okay, now we're going to go back to LabVIEW. I'm not going to close out my tank project. What I want to do is go and open up from the Getting Started window the dashboard project. And I want to give this some kind of cutesy name that I can remember. So let's call it 2016 video. And go ahead and launch that project. So actually I've started that before. Let's give it a new name. Let's call it Video B. Now as it opens up this project, what we're going to see As we open up the VI, this is the dashboard as we see it on during a match. I want to look at the block diagram, and what I can see here, if I get rid of this, are the while loops that run the dashboard. The one that I'm concerned about is the one down here with the camera display, and this is the button that enables vision. This vision control enables this video capture to work. If we go to the true case, we see here's how the images get displayed on the screen. Now what I want to do is put in my filter right here. I'm going to hold down Control, give myself a little bit of room, go out to my Vision and Motion palette. All right, this is a Vision and Motion, not the first Vision. This is the FRC, the NI Vision and Motion. The last little icon down here says Vision Express, and it shows me two icons, Vision Acquisition and Vision Assistant. Right now I just want Vision Assistant, and I'm going to place it right here. And as I do that, it now opens up Vision Assistant, and we're able to kind of utilize that extremely valuable tool. The first thing we want to do is go out and open the images that we just saved. So if we look at, and the folder I looked at was called New Images, so as you can tell I've done this before. Let's find New Image folder. All right, I'm going to select all of them, select the first one, hold down Shift, select the last one, and open. Now you see as we're sitting here, in fact as I'm looking at these, there's nothing moving. Makes me a little bit nervous that we waited too long, but let's go ahead and do it anyway. All right. And so that's loaded in our 60 images, and they're 246 by 172, and that's reason to be. All right, I just got one image. Let's try that again. Open image. Hold down Control, hold down Shift. Click on the last one. Open them. We want to replace what we previously had. Okay, now we got 50 some odd. And hopefully we've got some that are different. And I'm not seeing that. I'm going to go back and open up the images that I've done this before, where I was able to stop the acquisition and overwriting, and I just used that in images. So in essence, it should be the same thing. All right. What I want to do now is utilize this. We're going to start working on the first one. What I want to do is focus in on the yellow totes. So I'm going to zoom in a little bit. First thing I want to do is amplify the brightness. And I do this basically in an old-fashioned way. I'm looking at this as red, green, blue palettes or channels. And what we're going to do is saturate one and de-emphasize the other two. So we're going to move the contrast. I like to start with red, and you need to kind of go through this a couple times to see what works best. And the scheme I use is set the contrast high, the brightness, and the gamma low. And then for the other two, reverse that order. Set the contrast low and the gamma and the brightness high. And so probably realistically, we're saturating two channels as we go through this process. And what you can see here now is these are the response lines for red. Red is very standalone and isolated, and the blue and the green are very similar. So when we go to the next step, which is going to be under this particular function of color, we're going to extract a color plane, and by doing so, we end up with a very stark black and white image. What I like to do, again, because we're not using reflective tape, These are just the color palette that comes off the simulator. I like to strobe through each of these planes to see what works best, because sometimes something like this may be better than a straight dark black and white. But what we're looking for is the biggest contrast between the images that we're trying to filter out and the background. So this looks like the one that's going to work best for me. Next thing I want to go through is then identify in some way what this particular shape that I'm targeting and the size. So I'm going to go ahead and, with this little curly Q button, we're going to run a loop and put all the images through here. And what I want to do is be able to focus in on the image that's the right size and shape that we want to ultimately hone in on, not just something that's far away, if you will. All right, so you can see I've got a few of the right size images, and because I got these as I kind of scoped in, let's say that this is the size that I want to deal with. So I bring that over to the projection here, and I want to filter in on, or scope in on, this particular shape. So wherever it goes on the screen, I want to find it. I'm going to do that with a template. So I pick out this machine vision palette, and I'm looking for a pattern matching, which means I'm going to match it to a template that I save. So I pick out that step. I'm going to create a new template. It brings up this field over here on the right. I have the ability to zoom in and out, but right now I want to draw a rectangle around the image that I want to identify. And you'll see later how we may not always have it right off the bat. So I'm going to save this the way it is. We can deal with different aspects of it, and it's worth playing with that. For right now, I'm going to say this is yellow box just because I have it already set up. And what that does is gives me a template, and this particular step gives me the center of mass, X and Y position, the score, and the angle of rotation. Now, what I want to do is go through all the images and see if it starts to recognize the ones I'm looking for, and if it's filtering out the ones I don't want. So right now it looks like it's not capturing anything erroneously, but there are some images that maybe it's not identifying, so I need to fix that. So now as I go, let's say to this particular image, it finds one. Let's go to the settings tab, and let's say, what if I want to identify two? Now you'll notice it doesn't pick up the second one for probably a number of reasons, not the least of which maybe our score is set too high. So let's set the score down low, and sure enough it picks it up. You notice as I expanded the field of vision, it also makes apparently not too much of a impact. So there's a couple things going on. There's two other images here, and when I set the score very low, you can see this one here is down at 761 as far as the score. Let's move to some other images. Okay, it's picking up some erroneous images here because I have the score set way too low. So let's set a little bit higher and see what happens. So I got rid of those. Let's go back to where I have some more fertile ground to work on here. All right, and so now it's capturing this. First image is a score of 950, second image is at 843, and I guess I just want to deal with one at a time. So in my case, I'm going to bump my score up to greater than 800. Let's say leave it for matching one, and let's shoot for something for 700 for now until I find that it's not working. Let's go ahead and search on rotated patterns, see where else we're getting. Nope. Now see, there was something that when I picked up that one in the corner, the shoot in the corner, that's one I definitely do not want to have it recognize. So I need to go back and tune my filter. Let's look there. Tune my filter so that it doesn't pick up on that image. Right, so it's not. It just came across the screen. You get the idea. All right, once I've got a filter that identifies what I want, then I'm good to go there. And what we have is, let's see how this works. Okay, it's picking up primarily the totes that are in the center of the field. And some of the side ones. Okay, for my purposes, that's going to work because I'm going to place the robot at least in the general vicinity, and it should only have one choice to make when it starts into 0 and on the object or target I'm looking for. So let's stop this. Let's go ahead and convert this now to code for LabVIEW. I'm going to look at select controls down here at the bottom. I want to go ahead down here on the left-hand corner, create a destination image, and let's show calibrated matches coming out of it, and finish. And so now if we give it a second, it will come up with the LabVIEW code that goes in this particular location. All right, now I'm going to delete this line. I'm going to run the camera line through my icon or Vision Assistant icon that I've just generated. Let's pull this over here because I'm going to have to put in some logic. Now, what we're looking for is, this is the output from that last step, which included the score, the position, and the angle of rotation. Because I don't remember what's coming out of here, what I usually try to do is create an indicator to give me a clue what to look for. So if I go in and create an indicator, I can see that this thing is an array. So now I undo that, and I'm going to go in and index an array to be able to pull out that information. So we're going to bring this into here. Same thing again, we're going to create an indicator. Okay, now it's a cluster, which means it's been bundled. So we're going to unbundle it. And this is the position. So the position has an X and Y element. So we're going to unbundle it again. Now, because I want to see these as they occur, I'm going to create an indicator on the front panel. So as I change this to an icon so it doesn't take up so much space, we're going to do it again, create an indicator, and change it to an icon. Now we're going to find these, locate these, so we're going to find the indicator. And so it's put down here at the bottom, the left and right X and Y locations. Now what I want to do is save this, run it. Actually, I'm going to build it too. So let's save it. Save all. Close this down, go back to the project manager for this dashboard project. All right. Now we're going to build this, and this is going to put it in the location for the LabVIEW dashboard to pick up, and we should be able to see it as we're driving the simulator around. Now as I launch the driver's station, we should be able to display the dashboard now that in the LabVIEW format that we've built, and verify that we've got what we want. So let's go to our setup. Let's get rid of the default and go to LabVIEW. And as it takes the default out and brings up, you can see this is the one we built because it has the X and Y displays at the bottom. All right, I'm going to launch the simulator. Let's make sure everything's set up. We want to have the tank in my computer. Okay, we've got the driver station running. We've got our robot main linked to the simulator. We're going to launch the simulator and now drive it around and see if in fact our filter works. Well, let's see. Okay, because we hooked up the display from our filter to be displayed here on the driver station, that's what we're going to see. And we probably need to look over here to verify that we're aiming in the right direction. So let's kind of zoom in a little bit. Run this puppy forward. Need to enable our motors. Now granted, with all this stuff going on, it'll get a little slow. And I'm going to turn this off until we get closer, just because it... All right, let's get in a little bit closer. It speeds up when the video's not running. All right, let's go back and turn our camera on. And as we do that, we can see that we have a display here at the bottom. And so this is exactly the center of mass on the X and Y for whatever target we're looking at. As we turn, you can see now it's picked up on, and it's tough to tell which one it's looking at as we're currently sitting here. But the point is it's got something recognized, and right now because we have 3 images in the frame of view, it may or may not have the right one, but it's working as well as we hoped it would. The fact is that it's recognizing something and it's giving us coordinates here. So let's jump back out of this and go to the next step. I've closed the driver station, closed down the simulator. I still have open the project for the dashboard that we built a while ago. So let's go back to the dashboard. What I'm going to do now is use the coordinates that we see are working to identify the target and illuminate some crosshairs at the center of the screen whenever the particular target is in this specific range. So let's open up the dashboard main, look at the block diagram, and what this entails is essentially a new set of Vision Assistant requirements. So I'm going to make a little bit of room here for myself. Bring in Vision Assistant again. And this time we're just going to create some crosshairs. And to do that, I want to pick up just one of the images from our folder, and let's pick up one that's a little bit representative of where we're trying to go. And what I mean by that is that the image I'm looking for is going to be about the right shape and distance from the robot when we need to do some guidance towards it. So I'm going to pick out this one right here, open it up, and let's go ahead and zoom in a little bit. What I want to do is put a crosshair in the center of the screen so that when the measurements are in the specific range, the crosshair will illuminate. To do that, I come down here under the processing function image, and next to the last choice on the palette is called overlay. So we go to that step, and what I'm going to create, the way I like to do crosshairs, is do a rectangle, and I'm going to draw it somewhere near the center here. And I guess the area that looks like it works for my purposes, and this is one of those trial and error things until you get to an actual target, that for the vertical one, I need the left and right. You can see at the at this bottom part of the screen, it tells me where the cursor is, and as I drag these around, it'll affect these set points. But I want this to be at 120 and so the center is 120. So I want this to be at 110 and 130. So let's see what that looks like. The left side, let's set at 110, and the right side at 130. Well, that's not what I wanted. Oh, the left side, not the bottom. Let's cancel that all together and do it again. I want to do an overlay. I want to set a vertical bar for a rectangle. You can do this with lines, circles, or whatever, but let's do a rectangle. And here, I want the left side to be, well, this should be my lower number. So this will be my 110. And the right side should be my 130. So that starts to make more sense. And yet that's too big, so let's bring this down to 122 and 118. All right, so there's a shape of my crosshairs. I want to go ahead and fill this in, and I don't want it to be red because I have a red background, so I'm going to make this one green. Let's use that color. Now secondarily, I want a second rectangle, so we can OK this one. Put in a second rectangle, thusly, and it's going to be green, and I want the top to be, the lower number will probably be 80. So right there's 81, and the bottom I want to be, let's say 93, 92. Let's take the bottom down. It has to be greater numbers. Now you can see where we're going. As we do this, you can see how the lines are moving, and you can drag them around after you get done. But let's say we'd have this down a little lower on the screen because that's where our images are. And let's fill that in. Okay, so you got the idea that when we're in a certain range, I want these crosshairs to light up. So we're going to say OK on this. We're going to select the course. We want to have, let's go ahead and an image displayed here and finish it. Once it completes the icon, now I want to take my image and run it through my crosshairs. I'm going to delete this side, and this is the one I'm going to display. I'm not going to display the black and white image, so the operator can still use it. Now, what I want to do is set up a couple comparison channels so that I use some logic to control the illumination of the crosshairs. Okay, what we've done is created the crosshairs overlay with Vision Assistant. We've put it in a case structure, and when the case is false, the video goes directly to the display. When the case is true, we put our overlay on the image. The way we control that is we've determined what ranges, both for the, in this case, the X value and the Y value, what range we want to consider the target to be in our grasp. And we've used these two icons called in range. If I look at my context help, these come off the comparison palette, and it's called in range and coerce. We give it the upper and lower limit, feed the signal to the center, and if it's in range, we get a Boolean output. We take both of those Boolean outputs and we AND them together, and that's what causes our crosshairs to illuminate. Once we're out of that particular project, we have rebuilt the dashboard, and as we do this, it'll be stored and then will be picked up by the driver station next time we ask for it. So we're going to save this. And close it out. We're going to open up our basic robot that we're going to be driving around the system and launch it on the simulator. Now we've got driver station launched, and we've selected the default dashboard, and we're going to change that to the lab view dashboard because that'll pick up the one that we made. And you'll notice it has the X and Y display down here at the bottom, so that's definitely the one we've... Now I want to point out, you notice these errors from the last time we ran robot main, these are due to the watchdog timer, and this is why we go through the switch when we're doing a robot project. So if those of you that are not familiar with that, I invite you to find the tutorials that I talk about using the switch instead of teleop. Now we're going to launch this basic robot project to be able to run the simulator, and as we do that, we're going to be able to see whether or not our crosshairs are working on the video. So let's look kind of where we are here. Let's come back over here and enable the wheels. Our joysticks are in good shape. Let's move up a little bit. Okay, so we should be somewhere in the range of our camera being able to capture stuff. As we look at the display, there's sure enough where we're looking. So let's advance and see where we go. All right, you can see we have a display on our X and Y indicators, and sure enough, when it gets within a certain range, we get our crosshairs. Now, obviously, we don't necessarily want the center of the screen, but wherever our camera is aimed is where we want to train this particular focus. Okay, to me, that the significance here is multifunctional. First of all, we've done all of this in the dashboard, so we don't have to really change anything on the robot yet. And if the robot's not built, we can actually go through this whole process and debug a fairly sophisticated algorithm, and consequently learn a lot about video processing along the way. And if you got any questions, by all means, shoot me an email, jimc2550@gmail.com, and hope everybody has a good season. We will do a follow-up tutorial to this once I actually get a platform with a camera in it, and we'll use the LED ring lights and see how that makes a difference as far as our target illumination. Looks like it's going to be a fun season. I wish everybody the best. Have a good one.